Okay, so now kita tengok example 1. What is the de Broglie wavelength of an electron with momentum at exponent negative 24 kg meter per second? So we are given the momentum here, and then we want to find the wavelength. Okay, so this one is very straightforward. We know wavelength is equal to h, the Planck constant, divided by the momentum. So since momentum is already in SI unit, just masukkan sahaja 6.63 negative 34 divided by momentum at exponent negative 24, and then jawapan sama dengan 8.29 exponent negative 11 meter. So always leave your final answer in 2 decimal places. Okay, walaupun answer dekat sini dibagi dalam 1 decimal place only, but biasakanlah untuk tulis answer in 2 decimal places. Alright, so next one, example 2. Calculate the de Broglie wavelength of 0.2 kg tennis ball moving with a speed of 20 meter per second. Okay, so now we are given the mass of the tennis ball and then the speed of the tennis ball. So we are given m and v, and then we want to find the wavelength. Okay, selain daripada this formula, okay, we can find using another formula, which is lambda is equal to h divided by, okay, since p adalah sama dengan mass times with the velocity, so we can use h is equal to, lambda is equal to h over mv. So this formula is not given in the exam, so kamu kena hafal lah this one. So just masukkan 6.63 exponent negative 34 divided by mass, must be in kg, then times with the velocity 20 meter per second, so sama dengan 1.66 exponent negative 34 meter. Okay, next one. If the de Broglie wavelength of an electron is 2.5 exponent negative 10 meter, determine the velocity and kinetic energy of electron. Okay, so we want to find the velocity and then kinetic energy, which is K. Okay, so we know that kinetic energy, formula dia adalah sama dengan half mv square. So in order to find kinetic energy, we need to find the velocity first. Okay, so memang kena cari velocity lah dahulu. So how to find this velocity? Okay, using the same formula, which is lambda is equal to h over m times with velocity. So we are given here the lambda 2.5 exponent negative 10 sama dengan Planck constant 6.63 exponent negative 34 divided by m dekat sini adalah mass. So since yang terlibat adalah electron, so we need to use mass of electron, which is 9.11 exponent negative 31 kg. So this mass of electron is given in the list of constants. So kamu boleh refer dekat sana. So masukkan saja. And then velocity will be equal to 2.91 exponent 6 meter per second. So kalau ada velocity barulah dapat cari kinetic energy. Okay, just masukkan m is still the mass of the electron times with velocity, which is square. So don't forget the square. So kinetic energy is equal to 3.86 exponent negative 18 joule. Okay, last one, example 4. In a photoelectric effect experiment, a light source of wavelength 500 nanometer is incident on a potassium surface. Find the momentum and energy of a photon used. So we need to find the momentum and then energy, given the wavelength here. Okay, so energy. Okay, we know that momentum is equal to m times with v times with the velocity, but we are not given the velocity, so we cannot find using this one. And there's another formula yang melibatkan momentum, iaitu lambda. Okay, lambda is equal to h over p. So we can find the momentum here. So masukkan saja lambda adalah 500 nanometer equal to h is the constant divided by p. So momentum will be equal to 1.33 exponent negative 27 kg meter per second. And then next one is the energy. So energy of photon. Okay, this one adalah guna formula daripada chapter 9, which is E is equal to hc over lambda. So 6.63 negative 34. C adalah speed of light. 3 exponent f divided by the lambda. 500 nanometer. So dapatlah energy is equal to 3.98 exponent negative 19 joules. So jawapan yang dibagi ni salah. This one is the correct answer.